For more than 50 years, no human being traveled beyond low Earth orbit. For more than 50 years, the moon remained untouched by human explorers. Generations grew up knowing the moon landings only through photographs, documentaries, and history books. The Apollo era became a symbol of what humanity once achieved. But for decades, one question remained unanswered. Would we ever return? Today, that question finally has an answer. The mission is called Artemis II, and it represents one of the most important moments in the history of modern space exploration. Not because astronauts will land on the moon, not because they will build a lunar base, but because Artemis II marks humanity's return to deep space, a place no human has visited since 1972. To understand why this mission matters, we first need to understand what Artemis II is designed to accomplish. Unlike the Apollo missions, Artemis is not intended as a short-term effort. NASA's goal is much larger. The agency wants to create a sustainable human presence around and eventually on the moon. The moon is no longer seen as a destination. Instead, it is viewed as a stepping stone, a place where technologies can be tested before humans attempt missions to Mars. Artemis II is the first crewed step toward that future. The mission follows Artemis I, which successfully launched an uncrewed Orion spacecraft around the moon and returned safely to Earth. Artemis I demonstrated that NASA's new systems could operate in deep space. Now comes the next challenge: putting people on board. For the first time, astronauts will fly aboard Orion and leave Earth's immediate neighborhood. The crew selected for Artemis II represents a historic group of explorers. NASA astronaut Reed Wiseman serves as mission commander. Victor Glover serves as pilot. Christina Koch is assigned as mission specialist. Representing Canada is astronaut Jeremy Hansen. Together, they form a team that reflects the international nature of modern space exploration. Each crew member brings years of experience, training, and dedication. For Jeremy Hansen, the mission is particularly historic. He will become the first Canadian astronaut to travel beyond low Earth orbit. For Christina Koch, Artemis II represents another milestone in an already remarkable career. She previously participated in the first all-female spacewalk and spent nearly a year aboard the International Space Station. Now she is preparing for one of humanity's most ambitious missions. The astronauts have spent years preparing for every possible scenario. Training includes spacecraft operations, emergency procedures, communication systems, navigation exercises, and survival training. Every phase of the mission has been carefully rehearsed. Because once the spacecraft leaves Earth orbit, there is no quick way home. Deep space missions involve risks unlike anything experienced on the International Space Station. Distance changes everything. At the center of the mission is the Orion spacecraft. Orion is NASA's next-generation spacecraft designed specifically for deep space exploration. Unlike spacecraft used for low Earth orbit operations, Orion is built to support astronauts during long journeys far from Earth. The spacecraft consists of several major components. The crew module is where astronauts live and work during the mission. Attached to it is the European Service Module, developed in partnership with the European Space Agency. This module provides power, propulsion, life support resources, and thermal control. International cooperation has become one of the defining features of modern space exploration. The Artemis program reflects that reality. No single nation is carrying the burden alone. Instead, multiple countries contribute expertise, technology, and resources. The result is a mission that belongs not only to NASA but to a broader international partnership. But even the most advanced spacecraft cannot reach the moon without an equally powerful launch vehicle. That role belongs to the Space Launch System, commonly known as SLS. SLS is the most powerful rocket developed by NASA since the Saturn V. Standing taller than the Statue of Liberty and generating millions of pounds of thrust, the rocket is capable of sending Orion far beyond Earth's orbit. When the engines ignite, the rocket consumes enormous amounts of fuel in only a few minutes. The power generated during launch is difficult to imagine. For the crew, Launch Day represents the culmination of years of preparation. After boarding Orion and completing final checks, the countdown begins. As the clock reaches 0, SOS lifts from the launch pad and begins its journey into space. Within minutes, the spacecraft reaches orbit around Earth. But unlike missions to the International Space Station, Artemis II will not remain close to home. The mission profile calls for Orion to perform a series of maneuvers that gradually place it on a trajectory toward the Moon. As Earth becomes smaller behind them, the crew enters a region of space no human has visited in more than half a century. This moment carries enormous symbolic significance. The astronauts become the first humans since the Apollo era to leave low Earth orbit. The view from Orion will be unlike anything experienced by astronauts aboard the International Space Station. Instead of seeing Earth fill the sky, they will watch the planet shrink into the distance. A blue world suspended in darkness. Fragile. Beautiful. Alone. As Orion approaches the Moon, the crew will conduct a series of tests and demonstrations. Although Artemis II is primarily a test flight, the mission is far more than a simple engineering exercise. Every system must perform flawlessly. Life support equipment, navigation systems, communications technology, propulsion capabilities. All of these systems must prove reliable before NASA can attempt future lunar landings. The spacecraft will perform a close flyby of the Moon. This maneuver uses lunar gravity to redirect Orion and send it back toward Earth. During the flyby, astronauts will witness views seen only by a handful of people in human history. The Moon's cratered surface will fill their windows. Mountains, valleys, and impact basins will stretch across the landscape. Features that once appeared as tiny details through telescopes will become visible in extraordinary detail. Few human beings have ever experienced such a sight. The mission is expected to travel hundreds of thousands of miles through space. At its most distant point, Orion will be much farther from Earth than the International Space Station. Communications delays will increase. The sense of isolation will become more noticeable. Yet the crew will continue working through carefully planned mission objectives. One of the key goals is understanding how humans perform in deep space environments. While robotic spacecraft can travel almost anywhere, future exploration depends on human crews. NASA must learn how astronauts adapt to the conditions they will face during future missions. This knowledge will help shape plans for lunar bases and eventually missions to Mars. Mars remains one of the ultimate goals of human space exploration. However, reaching Mars requires technologies and operational experience that do not yet fully exist. The Moon provides an ideal testing ground. Lessons learned during Artemis missions will influence every future deep space expedition. In many ways, Artemis II serves as a bridge between the past and the future. It honors the legacy of Apollo while opening the door to a new era of exploration. The mission demonstrates that humanity is once again willing to venture beyond familiar boundaries. It reminds us that exploration remains part of who we are. Throughout history, humans have crossed oceans, climbed mountains, and explored unknown frontiers. Space represents the next frontier. The challenges are immense. The risks are real. But so are the opportunities. Scientific discoveries, technological advancements, international cooperation, inspiration for future generations. These are the rewards that come from exploration. For young people watching around the world, Artemis II may become a defining moment. Just as Apollo inspired scientists, engineers, pilots, and explorers, Artemis has the potential to inspire a new generation. Some of the children watching this mission today may one day walk on the Moon. Others may become the first humans to set foot on Mars. History often begins with moments that seem small at the time. A launch, a journey, a crew of explorers heading into the unknown. Years later, those moments are recognized as turning points. Artemis II may prove to be one of those moments. A mission remembered not only for where it traveled, but for what it represented. Humanity's return to deep space. A return to exploration. A return to possibility. More than 50 years after the final Apollo astronauts left the Moon, a new generation is preparing to continue the journey. The destination is familiar, but the future waiting beyond it is entirely new. And as Orion travels through the darkness toward the Moon, it carries more than 4 astronauts. It carries the hopes, ambitions, and curiosity of an entire planet. The next chapter of human exploration is beginning, and Artemis II is where that story truly starts.